This section of Chapter 2, Section 2.4, deals with the multiplication and applications of fractions. And so here are two objectives. Number one, to multiply a fraction by a fraction and multiply a fraction by a whole number. And then we solve applied problems involving multiplication of fractions. So here's the instructions for multiplying a fraction by a fraction. And so what we do is when we have, let's say, 9 divided by 7 times 3 divided by 4, we multiply 9 times 3. In other words, we take the product of the numerators and divide by the product of the denominators. So in this case, 9 times 3 is 27, and 7 times 4 is 28. So the answer is 27 divided by 28. It's a very simple process. For example, when we look at the first exercise here, 3/8 times 5/7. So we take the product of the numerators, 3 times 5, divided by the product of the denominators, that's 8 times 7. And 3 times 5 is 15, and 8 times 7 is 56. So the result is 15 divided by 56. Similarly, when we look at example number 3, excuse me. So we write the expression now as 4 times 8 divided by 3 times 5, which gives us 32 divided by 15. Sometimes these type of fractions are called improper fractions, where the numerator is greater than the denominator. But we don't really need to worry about that right now. Here's the answer, 32 divided by 15. And the next example is quite similar. So here we have, for the numerator, we have 3 times 1 divided by 10 times 10. 3 times 1 is 3, and 10 times 10 is 100. So the answer is 3 divided by 100. It's a very simple process. In exercise 5, we proceed the same way. In other words, we write the product of the numerators, 5 times 9, divided by the product of the denominators, 2 times 4. And since 5 times 9 is 45, divided by 2 times 4, which is 8, which is the answer to number 5. 45 divided by 8. Next, we have a guided solution. And so here, it's a little bit different in that we're multiplying a whole number times a fraction, 5 times 2/3. Now we know that we can write 5 as 5 divided by 1, and now it fits the pattern. We're multiplying, and to take the product of the numerators, 5 times 2, divided by the product of the denominators, 1 times 3. And since 5 times 2 is 10, and 1 times 3 is 3, the answer is 10/3. And exercise 7 is very similar. So here we have 3 divided by 8. And now we're going to write 11 as 11 divided by 1, because we know that 11 equals 11 divided by 1. So now it fits our pattern. We now take the product of the numerators, 3 times 11, divided by 8 times 1, or 33 divided by 8. So here we show you every step. In the future, maybe you can even skip a step or so, but until you really are confident and know what you're doing and understand the process, it might be a good idea to be very explicit about the individual steps you're taking. Let's look at some applications and problem solving. The first one is about a developer who plans to set aside 3/4 of the land in a housing development as open or undeveloped space. Of this area, of that 3/4, 1/2 will be green or natural space. What part of the land will be green space? So we follow our steps. The first one is familiarizing ourselves with the problem. So we can maybe make a little graph, a sketch here. It's not going to be very accurate, but let's say here's the total space, and so we're going to divide them into fourths because we're talking about 3/4 being set aside. So in other words, say this is the area for open undeveloped space, 3/4, 3 out of 4, and then half of this will be green or natural space. So 1/2 of this. So how much is that? Well, if we extend the line, we can see there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 units, so 8. And when we count how many are for the open space, it's 3 of them, half of this. So 3/8. So that's kind of what it looks like. But what about how do we translate that? Well, we have, in mathematical terms, we have 3/4, and half of that will be green or natural space. So this was the green or natural space. The word of implies multiplication. So now we solve this little problem here from what we've learned before. So here we're multiplying a fraction times a fraction. So 3/4 times 1/2 is equal to 3 times 1, the product of the numerators divided by the product of the denominators. And then we find that's equal to 3 divided by 8. Step number 4 is to check what we've computed here. And first of all, the math, the computations are correct. It also matches with the initial familiarization of the problem here when we did the little sketch here, that this will be the green space here, half of the 3/4. And so the answer checks in both ways. Answer checks. And so we can state that 3/8 of the land will be green space. 3/8 of the land will be green space. That's the statement. Here we state our answer. Let's look at number 9, area of a ceramic tile. The length of a rectangular ceramic tile inlaid on a countertop is 4/9 feet. The width is 2/9 feet. What is the area of the tile? Okay, so here's a bit of a sketch. It's already done for us. Here's the length, 4/9 of a foot, and the width, 2/9 of a foot. So to familiarize ourselves with this problem, we remember that area equals length times width. So we let A equal the area of the tile in square feet. So the unit of measure, we want to make sure we get that right. And then number 2, we translate this into a mathematical statement. So translate. So we say area A equals length times width. So that's 4/9 times 2/9. And then number 3, the step would be to solve. So A equals 4/9 times 2/9, or 4 times, well, let me write it down. 4 times 2 divided by 9 times 9. So it's equal to 8. 4 times 2 is 8 divided by 9 times 9, which is 81. So we check the answer. Again, we just look at the calculations, and we find that 4/9 times 2/9, that's correct. 4/9 times 2/9, 4 times 2 is 8, and 9 times 9 is 81. So that checks. And number 5, point 5, is we state the answer. The area of the tile is 8 divided by 81 square feet. Again, what we call the unit of measure is just as important as the answer, because without that, we have to guess what is meant by this answer. So this is absolutely critical to have the correct unit of measure. In exercise 10, we are asked the following. Of the students at Overton Junior College, 1/8 participate in sports, and 3/5 of these who participate in sports play football. What fractional part of the students play football? So first of all, we familiarize ourselves with the problem. Familiarize. So let P be the fractional part of the students who play football. Number 2, translate that into a mathematical statement. Translate into a mathematical statement. So to translate is we are finding 3/5 of 1/8. So the multiplication sentence 3/5 times 1/8, remember of implies multiplication, equals P, corresponds to the situation. So that corresponds to the situation. And number 3 is to solve. So we multiply 3/5 times 1/8, which is 3 times 1, divided by 5 times 8. 3 times 1 is 3, and 5 times 8 is 40. Therefore, therefore P equals 340. And number 4, we check the answer, check the arithmetic. And so we again go over the initial multiplication sentence, 3/5 times 1/8. And so the calculations are correct, so that checks. And number 5, we state the answer, and that is 3/40 of the students play football. 3/40 of the students play football. And there you have it. And this concludes section 2.4. And as I mentioned in previous sections, to do applied problems, it takes a little bit of different thinking than just simply multiplying fractions. And so therefore, I'd really recommend you do some additional exercises in section 2.4. And so you can do some drill exercises on page 113 and some other applications on page 114. So pages 113 and 114 will give you some additional opportunities to deepen your understanding of what section 2.4 was all about.